Hi everyone, this is a drop-in Q&A session as we do every Sunday for about an hour, so please let me know if you have any questions or anything you want to particularly go through. It could be a specific topic, it could be a specific question from a past paper that you've been through. Histograms, yep, we can look at histograms. Yeah, it's a fairly big topic, histograms. I think that's the thing. There's quite a lot of different things we need to know how to do, and they're all a little bit different. So are you happy with... The first thing I would say is drawing a histogram, plotting it. Are you happy with that bit, or do you want me to go through literally from the beginning? Let me know kind of from which point you want me to go through. Yeah, let's go through everything. So yeah, as I said, I think the first thing is being able to plot one. If they just give you a table, a frequency table, and then you have to be able to plot it from there. That's the first thing. So let's just do that quick. I'll grab some questions. Yeah, hopefully this isn't too blurry. Let me just see. A little bit, I think. Can you read that? Hopefully you can read that. Just doesn't let me copy and paste very well. Okay, that one's a bit better. So we've got this, and then I'll put our table just over here so we can see both. Okay, let me grab my pen. Okay, so obviously as a context, so in this case, the table gives information about the distances in miles that some year 10 students live from school. So you're going to get a frequency table. Now, you get frequency tables in quite a lot of topics, so it's just being really, really clear what topic this is, how that's different to, for example, cumulative frequency, frequency polygons, mean from a frequency table. All of these things, they all kind of stem from a frequency table, but obviously histograms is different to each of those. So what we have to do in our histogram, you can obviously see in this one they've already shown you, obviously the x-axis is in terms of distance. It will always be this kind of column with the ranges, so that will always be the x-axis. Obviously the context might change, but then the y-axis, you can see obviously in our other column we've got frequency, but our y-axis is frequency density. And that's not the same thing. So what we have to do first is convert all of this table into frequency densities. So this is the formula triangle that I like to remember. I like to use a formula triangle for most things if I can. Its frequency goes at the top, and the way I remember that is because it's the only one with a single letter. Frequency density and then class width go at the bottom. You see how those have both got two letters. So that's how I remember which one goes at the top. It doesn't matter which way around the other two go as long as they're both at the bottom, right? So we obviously want to find out the frequency density, cross that out. Do you see how I would have to do the frequency? So this column divided by the class width. Now the class width is the difference between these two, for example. So the first one for this would be, you can create another column if you want on your table. Frequency density, I would do 90, put it over here for your calculation, divided by the class width. Now do you see how the width of this one is 1? Between 0 and 1 is a width of 1, isn't it? So that would still be 90. And then this one, 48, do you see how this is now a class width of 0.5? Yes, I'll check my email once we've done histograms, okay? And then we'll look at whichever question you've sent me. That's fine. So do you see how the class width is 0.5? That's what I mean by class width, okay? So that one would be 48 divided by 0.5, which I'm pretty sure this was a calculator question, right? So obviously, if you wanted to, you could use a calculator, but it's basically doubling it. So that'd be 96. Again, this is divided by a half, so that'd be 44. This one, though, just be careful because they are all so different. You can email me. My email is the same as my channel name, right? So GCSEMathsPro and then @gmail.com. I think it's on the channel description if you look at, when you go onto the actual description part, I think it's there, I'm not sure. But if you have any specific questions, you can always email me. So just be careful because all of the ranges here sometimes are different, right? So the next one is 8. The class width is 1, so that would be 8 divided by 1, which is obviously 8. And then this last one's actually 2, so 12 divided by 2 is 6. So I've worked all of those out, and then obviously I now need to plot it. Now in this particular case, they haven't given you a scale for the frequency density side. Sometimes they will, sometimes they won't. You have to then figure it out. So I'm just looking, what's my biggest number? well, it goes up to 96. So I'd probably round that to like 100, you know? And I'd count these and go, right, there's 1, 2, 3, 4, 5, technically 6 squares. So what I would probably do is maybe mark each of them as 20. So that's 100, 80, 60. And that's how I would spread it out. You can spread it out kind of, you know, depending on the numbers, whatever makes sense to you. That's 40 and that's 20. Let's go with that. So then you just plot it on. Obviously at this point, you have to remember what a histogram looks like, right? It's effectively, it looks like a bar chart, but obviously all of the bars are different widths as well as different heights. Ratio problems, yep. So after we go through histograms, after I go through the question that someone sent me on the email, then we can look at ratio, okay? I'm just going to go in order that the questions are sent in, basically. So I'm going to get straight line. So here we've got, that first one was at 90, so it goes up to 90, but again, remember the width of it is from 0 to 1, so, oh, that's not 90, is it? Let's go to 90, there, halfway between obviously 80 and 100, depending on your scale. There. And then we've got, the next one was 96, so that would be 3 squares above, wouldn't it? And do you see what I mean? I'm just plotting it, and it's now, this one, just be careful, because this one's like half across, isn't it? Where's that? About here. And then down to 1.5. The next one is at 44. So 2 squares above 40. And again, halfway for that one. This live will go on probably for another hour. Okay, so I'll probably finish at about 5:45-ish. And then the next one is 8, so it's all the way down here, but remember that one is the whole way across to 3, isn't it? So what's that? 4 squares up and then across, and you get the gist from here. The last one is obviously 2 squares, the 2 whole squares across, and then up. So that would be 10, that'd be 12. This would be 12, wouldn't it? So that's how you plot a histogram. You have to have the frequency density. If they've given it to you already, then you won't need to do it. If they haven't given you the frequency density, you'd have to work that out, okay? So that's the first thing. The next thing is, I think in my head I split histograms into 4 things. The first one, as we said, is plotting it, right? You've learned how to plot it. The second one is some kind of interpretation. It's quite a random question, this one, but it's kind of interpreting interpreting the histogram. Maybe there's bars missing, things like that. Sometimes you have to add up the squares. Sometimes you have to work out the frequency and use this formula tree. Then after that, we've got working out a median, lower quartile, upper quartile, interquartile range, you know, all of that stuff. And then the last thing is the mean, working out the mean. So that's kind of what I'm splitting it into in my head, right? The only thing is the interpreting ones can be a bit random, can't they? It could be anything. So let me find an interpreting one. Yeah, here, this one. Let's do this one. Copy this one here. This one is 3 marks. Question 13. So this one's not too far through the paper. It is calculator, this one. So you can use a calculator. Okay, so in this case, they've obviously drawn the histogram for you. The histogram shows information about the ages of 134 members of a sports club. So you know the whole thing would add up in terms of a frequency to 134. Should I have a title? You don't have to give it a title, no. I don't think I've ever seen them ask for a title. No. If they say plot it, they just mean, like, obviously make sure you've got the axes, right? Sometimes, let's say if they didn't write down frequency density or one of the axes, you'd have to write that. And obviously you'd have to write the scale and then draw it, but there's never normally a title. No, I wouldn't worry about that. Okay, so this histogram is representing 134 members, so that's obviously key information there, isn't it? That's the total frequency. 20% of the members of the sports club who are over 50 years of age are female. So that's then kind of more information. So over 50, where's 50 on my histogram? Maybe let me get colour. So 50, they've done that deliberately, because you see how it's not just a whole block, is it? It's halfway between this block and then also including, if I get my highlighter, do you see how that would include this bit here, all of this bit, plus, and what they're saying is that those two kind of blocks represent 20% of the 134. Work out an estimate for the number of females who are, so work out how many females there are over 50. So I need to first work out, do you see how this is what I mean by like an interpreting question? There's normally some kind of percentages, maybe we're kind of given a histogram, we have to work backwards. So again, you might want to have your formula triangle, because you can use this to work out any of these three. Obviously on your histogram, you can see the density, the frequency density, you can see the class width. So the only thing that it would be helpful for is to work out the frequency. So I guess you could do it in different orders. I mean, they've said that 20% of the members. So you could work out Oh, 20% of this, yeah. So I would work out how many members are represented by these. When I say bars, I mean, obviously this is half a bar, isn't it? So let's start with the main bar. If we just look at this first one here, 60 to what's that? That looks like 90, doesn't it? 60 to 90. So I want to work out the frequency. So cross that out, that's multiplying, isn't it? So my frequency density, if I go across, just read that off really carefully. I want to make sure I've got the right one. This one here. 1, 2, 3, 4. I don't think that's quite halfway. I think that's, is that 0.7 maybe? I don't think it's quite 0.75. Will you lose marks if you don't show you're working out? It depends on the question. I would suggest yes, because if you've looked at a mark scheme, they normally specify mark number 1 is for writing this. Mark number 2 is for writing the next thing. And obviously then your final mark, you only get 1 mark for the answer normally, isn't it? You get 1 mark for your answer. So if you don't write the working out, you might only get 1 mark. You might only get, and if obviously if it's right, if it's correct, you might only get the answer mark. Do you see what I mean? Because they'll be looking for your working out. And they'll be looking for a specific line of working out, a specific calculation to give you each mark, if that makes sense. So I would say, yeah, I think they would lose marks. You have to always show your working out. I would always show my working out. Especially because if your answer is wrong and you've not written anything else, then that's such a risk, isn't it? Because you might get some marks in your working out, even if your answer is wrong. But if you don't write anything and your answer is wrong, you've got nothing, haven't you? So I would suggest yes. I've also seen, it depends on the question, but I've seen a question where they said if only the answer was given, they would give you no marks. Like they wanted to see the working out. So yeah, I would always write your working out. But I don't know how you would do most of this in your head anyway, to be fair. I think most of it you would have to write down, surely. So I'm going to work out frequency. So as we said, I'm just working out the scale of this side. So it's 10 squares for 0.5. So 0.1 would be 2 squares, so that'd be like 0.6 when it's 0. I think that's 0.7 there. Just be careful of that. And then I'm multiplying because it's across in my triangle, and then my class width, do you see, is between 60 and 90, so that's obviously 30, isn't it? That's basically 70% of 30, but this was a calculator one, so you can look that up, so which is 21. So that represents 21 people, just that one there, this one here. We obviously now need to work out the second bit, right? Now, you can either work out the whole of the 40 to 60 bar and then half it, because it's obviously half, or you can just use your class width as 50 to 60, which is what I'll probably do. So the frequency of the second one would be, what's that? I think that's 1.4. Frequency density is 1.4 times by the class width, which I'm going to use as just 10, because it's between 50 and 60. That's obviously 14, isn't it? Okay, so the total of over 50s, add those, is 35, isn't it? There's 35 people who are over 50. Now they've said 20% of that number are female. So they said how many are female. Well, I just need to work out 20% of 35, which, because it's a calculated question, I would just multiply it by the decimal. You work it out however you want, as long as you get the same answer. And I think that should give us 7. Yes, 7. So that would be your answer. But you see how that's kind of a bit of interpreting. I've had to use my histogram to work backwards. I've used this formula triangle. Sometimes you might, if you're not given a scale for frequency density, if it doesn't say anything, you might want to count the literal squares, like the literal squares in it. You could use that as well. But it's kind of just using this triangle to help you work backwards to find frequencies. Sometimes there's percentages in there as well. So the interpreting ones are all a bit random, okay? So you just have to kind of just go through past paper questions to see all the different types. So moving on, the next thing is median, upper quartile, lower quartile. Those all in my head come under the same kind of category. So yeah, let's do this question here, and then we'll do the mean, and then we can look at the next thing, okay? But it's just histograms is such a big topic, that's the thing. So this one, again, they've given us the histogram already, and then I just need to grab, hang on, let me just grab the table. Because we need to have the table. Part A was just to work out the table, so we'll have to do that first before we can work out the actual question, part B. So let me move this around a bit. No, don't zoom out. Histogram, table, and then the question here. So, in this case, the histogram shows information about the times taken by some students to finish a puzzle. So this is in terms of times. First of all, we need to complete the frequency table. So you see how we'd be going backwards there, wouldn't we? We'd use obviously our formula triangle. We need to work out the frequency, so we've just done that, haven't we? The other one, you just multiply them. So for example, for the first one, they've already done it, but they've obviously done, that was obviously 5, wasn't it? 5 times 0.8, which gave them 4. The next one, we've got frequency density of 0.4 times by 10, so that's obviously another 4, and then that's 25 there, isn't it? We've got 0.6 times another 10, so that's 6. The next one is 1 times 5, 5. And then the last one is 30 to 50, that's 20 times 0.2, so I think that should be 4. Let me just make sure I'm not wrong. Yep, 4. So I've just quickly done that because that's just using the frequency, well, the formula triangle, isn't it? And then this is the bit I wanted to show you, was in this particular case, they've asked for us to find an estimate for the lower quartile. Now, this, I'm going to show you the lower quartile, but this would work, the same method is pretty much the same for the median or the upper quartile as well. So it's all 3 in 1, really. Obviously, it just depends, you know, the starting point is different because it's lower quartile, median, or upper quartile. So the lower quartile, find an estimate. So the lower quartile, and this is for cumulative frequency, this is for box plots, this is kind of for everything, is always 25% of the data, or in this case of, how was it, number of students. This is 25%. So I almost, on my table, like to find a cumulative frequency. What I mean by that is, you know, when you add them together, so that's 4, that would be then 8. If I added 6, that'd be 14, 19, 23. And then I need to figure out what is 25%, I guess, of the total. The total frequency is 23, isn't it? The total frequency. Now, because it's an odd number, if you want to, you can make it even, as in you could make it 24. So I'm probably going to do that. But they won't, I think in the mark scheme you could do either. So. Oh, is it back? No, my laptop just shut down for some reason. Is it back? Is it reconnected? Guys, let me know if it's back. My laptop just shut down. Hopefully it's reconnected itself. Just let me know if you can hear it, or if, I don't know if it needs restarting. It's back now? Okay, perfect. So what I was saying is if it's an odd number, the total here, do you see this total? You can make it even if you want. So I'd probably just make that 24 by adding 1. Now I want to know 25% of, because it's the lower quartile, right? I want 25% of that, which is just a quarter, isn't it? So I'd just do that. So 24 divided by 4 is obviously 6th. So that's the 6th person. Now, if this is where it's different, if you wanted the median, you'd obviously not divide it by 4, would you? The median would be 50%, so you'd just divide it by 2. The upper quartile was 75%, so you would work out maybe a quarter 6 and then times it by 3, for example. So that obviously changes depending on which of the 3 things they've asked for, but the logic is the same. So I'm looking for the 6th person. Now, this is why I've also done my cumulative frequency. If you were to line up all these people in order, I added 1 just because I didn't want to have to... If I divide 23 by 4, I would get a decimal, wouldn't I? It'd be kind of an annoying answer. You don't have to. You could just divide it by 4 and go with that if you wanted to. But I just prefer, you are allowed, like you can technically, if it's an odd number, the total you can add 1 to make it even. That's just a personal preference. But they will allow both. They will allow you to either add 1 just to make it even and work from there, or they'll allow you to just do it like 23 divided by 4 directly. The only thing with that is, what would that give me? That would give me 5.75, and I would just, personally, I'd rather not deal with 5.75, but that's just me. So it's up to you. Anyway, so it's the 6th person or the 5th. You might have got 5.75 person, but again, that's not, because we're talking about people, it's not like a whole person, is it, I guess? And they've also said an estimate, so it's kind of just roughly, you know? So once we do that, I want to know, where does my 6th person lie? If I were to line up all these people, obviously in the order that they did the puzzle, right? So from 0 minutes up to 50 minutes. Where does person number 6 fall? In which of these rows does person number 6 fall? Which is why I wrote down the cumulative frequency. Do you see how person number 6 would fall in this row? Because obviously the first four people, that's not enough, is it? I need person number 6 is in the first row. And then after that, there's another 4 people, which goes up to person number 8. Do you see how person number 6 would fall into this row? You'd have to figure out, obviously, depending on the median, interquartile range, or whatever, upper quartile, which one they would go, in which of these rows they would fall. Obviously, all of them will be different. The lower quartile should obviously be one of the first few rows, shouldn't it? So I go, okay, well, obviously, my lower quartile is going to be somewhere. Is it working, guys, or is this signal not very good? Just let me know if it's not very good signal. Well, internet, I guess. It's obviously the lower quartile is obviously between 5 and 15, isn't it? But then, oh, okay, at least okay, it shouldn't be me then. Okay, yeah, sorry, Emily. At least I don't think it's on my end. Yeah, so my lower quartile, I now know, is somewhere between 5 and 15 minutes. But obviously, I don't want a range. I want a more specific answer. So that's why I need to now go a step further and go, okay, well, what's my estimate for where person number 6 would fall between 5 and 15? So this is the bit I think people struggle with a bit more, is getting their head around it. Do you see how there are 4 people in this row? There's 4 people here between 5 and 15. I want person number 6. Who is person number 6? Well, given that the row started after 4 and ends at person number 8, number 6 in this case would be halfway, wouldn't they? Do you see how person number 6 would be halfway into that row? Because they go from 5, 6, 7, 8. They're basically halfway into that row, aren't they? I don't know if that bit that's the bit that's kind of tricky. You're trying to figure out how far into the row is the person I'm looking for. I can see, because the row is going to start, if I took away the previous 4 people. Do you see that? If I take away the 4 people that were in the previous row, because I don't want to include those, do I? That would be 2 people, the second person. Do you see how that's the second person in this row? That would be the second person out of 4 people, which is half, isn't it? That's where I'm getting the half from. So then I apply this fraction to my actual class width. Now the class width is 10, isn't it? Between 5 and 15 is 10. So do you see how I would get, that would give me 5, wouldn't it? Now I've converted it into minutes. Now that's not the answer though, it's not 5 minutes, because obviously 5 minutes would be in this row, wouldn't it? What it is 5 minutes into the row. So from well, this is confusing because they're both 5s, from the starting value, which was 5, it's another 5 minutes. So I'd have to add them. Do you see how it would give me 10 minutes? That would give me 10 minutes. They have said 10, or they've said technically in the mark scheme, if you did the 5.75, if you didn't add the 1 originally, you could also have said 9.375 minutes, but you see how you get loads of decimals there, so I just avoided that. So this is exactly the same for the upper quartile or the median. The only thing is obviously at this point here, you change the calculation depending on if you're working half, if you're working out a quarter, if you're working out 3/4. Obviously that bit changes, but the method beyond that is the same. I just think this bit's kind of tricky to get your head around. So I don't know if that makes sense, or if you're not sure what I mean by that. Because that's the bit that's kind of tricky to get your head around. How far into the row that I've identified is that person, and then apply that as kind of like a fraction of the class width. The 10 here was the class width, just in case you're not sure where that came from. That's the class width. So 2 out of 4, yeah, that's the bit I think that's confusing. Why do I do 2 out of 4? So I think up to this point is probably fine. You're like, okay, yeah, the 6th person is going to give me the lower quartile. So then do you see how I went through and said, well, which row is the 6th person in? Obviously in the 2nd row in this particular case. Obviously it will change depending on the question. But then what I need to do is narrow it down. Do you see how? Because I don't want to give my answer as somewhere between 5 and 15, because that's still quite a big range, isn't it? I want an actual answer for my lower quartile. So I then need to go a little bit further and figure out, okay, person number 6, where are they roughly in this between 5 and 15? Where are they? So where the 2 out of 4 comes from is obviously, see the frequency was 4. Let me get colour. That's the 4 there. That's why I've got a 4 here, right? Because out of the whole row, there's 4 people, so that's the denominator. Now the 2 is probably a bit more confusing. The 2 I got from here. Do you see what I did? I need to get a different colour again. Now it's confusing because there's so many of the same number, so you're not really sure why I've used that number. Like this 4 here is this one. So I said, okay, it's the 6th person from person number 1, but obviously person number 1, 2, 3, and 4 are in the other row. They're not in my row, are they? They're in the other row. So I was taken away. I was saying, well, okay, get rid of those first 4 people, right? Because they're in a different row. So then that leaves me with 2 people to get to number 6, doesn't it? So you see how that would be 2 people into the pink one. 2 people into this. So that's 2 out of 4. I don't know if that makes more sense. I've kind of tried to colour code it. Yeah, Emily, we can do that. I'll just add it to the list. We've got histograms. Once we finish histograms, I'm going to go through a question that I've got emailed. I think, were you after that, or was there someone else after that asked a question? I think you were the one who asked. Oh no, ratio from Reese, and then your question. So, Vanessa, I don't know if that kind of explains where I got the 2 and the 4 from to make 2 out of 4. And I do it as a fraction because I want to find kind of what proportion of that row is number 6. It's technically halfway into that row, isn't it? So that's the bit, I think that's the bit that's confusing. Obviously those numbers all change depending on the question. So then I got 10 minutes. So that's the lower quartile, but as I said, you can apply that to any of the upper quartile, median, lower quartile. It works for all of them. Obviously you just do a different calculation at the start to find out if it's the 25%, the 50%, or the 75%. That's the only thing that changes. Otherwise, it is consistent. So, okay, the last thing on histograms that I'm going to go through is the mean, but I think that's fairly straightforward because if you can do, I'm hoping you are confident with finding out the mean from a frequency table, that's effectively what it is. Well, that's how I would work out anyway. David's going to let me copy it. So it's kind of 2 in 1. It's like the same question, but obviously in the context of a histogram. That's how I would work it out. So we need to know how to do mean from a frequency table anyway, because that could come up quite easily, and that's a really nice kind of 3-mark question. So you see here, we've now got the histogram gives information about the distances 80 competitors jumped in a long jump competition, obviously distance and then frequency density. Calculate an estimate for the mean. So what I would do in this case, get my triangle back again. I want to work out my frequency, as people do it differently, right? But this is how I would do it, is I want to get my frequency table back. So kind of what we did in the other question. So it's a little bit repetitive in that sense, which I guess is good. Well, let's not have a pink table maybe. So, I mean, you could just scribble this, doesn't have to be, you know, it doesn't have to look good, but I'm just going to try and make it look fairly decent. So, frequency table, so in this case we've got distance here, and then we've got obviously frequency that we want to work out. Remember that we did, to work out frequency, we just multiplied them, right? So we've got from 6.4 to 7.2. You don't have to write it kind of fully like this. What am I going to put for distance? Oh yeah, they put meters, haven't they? Doesn't really matter, does it, I guess? As long as you can read it, then it's fine. Let's do that. So that one, what was that? That looks like, to me, that looks 10. Look, it's 10, and it was a difference of 0.8. So 0.8 times 10 is 8, isn't it? So that's 8 people. Obviously, the frequencies should all be whole numbers. So if you don't get a whole number, you know something's wrong. Here, this one looks to be at 50. And then what's that? A difference of 0.4. So I think that would give me 20. We've got 7.2 to 7.6, just because we're going to use this range afterwards, so I'm writing it down. And then this one, 7.6 to 8. We've got, what's that? 100. So 0.4 times 100 should give us 40. And then the last one, 8, what's that, 8.2 to 8.2, obviously make sure we read it off properly, and then that's at 60, so 60 times 0.2 is 12. Okay, now obviously that should, I guess, technically add up to 80. Yeah, it does. Okay, so I know I've got that right. Adds up to 80. Now, from a frequency table, I can almost forget about my histogram now, because I can just use this as mean from a frequency table, can't I? That's why I'm doing this. So normally what I would do is add 2 more columns to my table. If I'm doing mean from a frequency table, I would add 2 more columns. One is for the midpoint, isn't it? And then the other is then when we start calculating things. So we have to write down the midpoints of each of these. If you're not sure how to work out the midpoint, like if it's not super obvious, I think the first one's not very obvious, what you can do is just add them together and then divide by 2. Because that's effectively finding an average, isn't it? Which is the midpoint. So that would give me 6.8 for that one. The next one I think is probably a little bit more obvious, isn't it? So that one you probably don't need to try and figure out. But yeah, you can use that method if you're not sure what the midpoint is. Add the 2 numbers together, divide by 2. That one should be 7.8, and that one, I mean, this one's, the last one's probably the most obvious, 8.1. So there's my midpoints. And then from here, just remember again, this is just mean from a frequency table. I'm not even worrying about my histogram anymore. We multiply them, don't we? We do frequency, where's my pen? Frequency multiplied by the midpoint. That's what we do, isn't it? So then we'd multiply this. This is obviously a calculator. This was from a calculator question, so you don't have to work it out yourself. If they did it on a non-calculator, it would just be, you know, nicer numbers. So that's 54.4. 20 times 7.4, 148. 40 times 7.8, 312. And lastly, 12 times 8.1, 97.2. Then we add that column, don't we? Again, I'm just following this same method from that other topic, mean from a frequency table. It's not anything new. When I add it, it gets 611.6. And then the last thing is you divide it by the total, which is the 80, isn't it? Divide that by 80. They haven't said how to round it, so I'm just going to write all of the decimals because there's not too many. That's what I got, 7.645. Okay, so this one I actually wouldn't do anything, like it's not really a different method. What I would do is just use my triangle to find out the frequency, create that table, kind of go backwards to create the frequency table, and then I would just use what I know how to do mean from a frequency table. So that's quite a nice one actually. I know people do it differently to that, but I think I would just focus on it that way, so then at least it's only one method that would cover 2 questions. So I only have to remember one thing, if that makes sense. So that's what I would say. I think that kind of roughly covers most of histograms, right? Obviously, there could be different questions on the interpreting one, but in terms of that, we've gone through how to plot a histogram, maybe just one question on how to kind of interpret a histogram using percentages, things like that. We've then done lower quartile, kind of median, upper quartile, and then mean. I think I would suggest, cover the majority of what comes up in histogram questions. If not, then obviously just remember this formula triangle, and you can use that to work out any piece of that triangle with that formula. Okay, so hopefully that answers your question on the histograms. The next one in the list, someone sent me something. Hang on, let me just have a look at it. I think we've got one question particularly. Oh, I've never seen this question before. That's interesting. Looks like a prism. I'm going to copy it in a minute. Hang on, give me a second just to look at it. Pyramid, and then what's that, an octagon? Yeah. Okay, let me see if I can copy this. I need to download it and open it, I think, actually. This might be blurry, so let me just see if I can make it bigger. Oh no, you can still read that. Okay, that's fine. Okay, so I've just been sent in this question here. I've not seen this question before, so I don't know if this was from the 2024 papers or where this was from, but it looks kind of interesting. So question 22 is obviously at the end of the paper. I don't know how many marks it was. I would assume, I'm assuming more than 3 by the looks of it. So we've been given a greenhouse consists of a pyramid on top of a prism. So you can see they've given you the heights of both separately. I'm assuming this was calculated based on those numbers. Then we've been given the cross section of the prism, and the base of the pyramid is a regular octagon, so a regular one. So all of the sides are the same, all of the angles are the same. Each side of the octagon is 0.8 meters long. The height of the prism is 1.73, you can see that. And then obviously the height of the pyramid, is 0.68. That's okay, we've just started, don't worry. We've just started. I'm just reading through it, basically. Calculate the volume. Okay, so volume, that's interesting, yeah. Okay, so I would think of this in 2 separate pieces. You've obviously got as I said, you've got a pyramid at the top, that's one thing, isn't it? Then you've got a prism. Now, working out the volume of any prism, you work out the area of, as they've said, what do they call it? The cross section, yeah. And this is this bit, isn't it? So we'd have to work out the area of the octagon, which I know we don't necessarily have a formula for. But we'd have to work out the area of the octagon, and then we would just times it by the 1.73. So that bit, once you've got the area, that bit's okay. Now, volume of a pyramid, because a pyramid's obviously not a prism, I would have assumed that they would have given you the formula for that, because that obviously has its own formula, doesn't it? I would have thought they would have given you that because it's not a prism, but I'll write it here. The volume of the pyramid, length times width times height over 3. I guess that's not too difficult to memorize, actually, is it? Yeah, I can see. Yeah, this is definitely a calculated question. Do you know how many marks this was, by the way? I find that quite interesting to know, kind of, therefore, how hard I would, in my head, I kind of assessed how many marks a question is, how much space they've given me. That kind of gives me an idea as to how much working out. Yeah, so the octagon, what I would do with that, because we don't necessarily have our own formula for that, do we? What I would recommend is kind of splitting it. You can always split up shapes. So if you you can always draw lines on any of your questions, right? You can annotate it however you want. No, that one goes here. That one goes here. Do you see how this creates triangles? That's probably what I would do. Yeah, and then as you said, you work out one of those triangles, you can times it by 8 to find the whole thing. So that's probably what I would do for that. We could do the pyramid first, I guess, couldn't we? Okay. Well, that's quite interesting because the pyramid is says length times width times height, but that's if it was a right, no, that's if it's a right rectangular pyramid. This is not a rectangular one, is it? So I would assume it doesn't work the same way, because obviously I would assume that works differently. Let me have a look. Maybe that's why they didn't give you the formula. I think it's just the area of the base, because I guess that would be for, a square or a rectangle, length times width, wouldn't it? Yeah, so I think we'd need the area of the base times it by the height and then divide it by 3. I think that's what they're saying. So let me rewrite that, because that's obviously for a rectangular one, isn't it? So I'll put A for area, right? Area times the height over 3. Okay, so either way we need to know the area then. That's kind of, I guess, the main bit. Yeah, they didn't give you the formula. That's interesting. It wasn't on the formula sheet or anything. Yeah, if you can put in the comments what you would do, that's fine. So, area of the triangle. These are obviously... We need to look at what type of triangles there are, don't we? I'd say these are isosceles. I wouldn't say they're equilateral. They're not equilateral, but they're isosceles. So what I would have thought to do, and I guess there's probably different ways to do this, but what I would have thought to do is that formula for angles in polygons. I mean, unless you know it, unless you know what an angle in an octagon is, but I don't think anyone's memorized that, is n minus 2 times 180. That will give you the total. Because it's regular, if you divide that by how many sides there are, it will tell you one of the sides, like one of the angles, if that makes sense. So I would have done that. In this case, obviously n is 8, right? It's an octagon. That gives me, no, it gives me double that. 135 degrees for each angle. Now, but obviously that's one whole angle, isn't it? So I'm thinking of my triangles. What I would have done is halved that, right? So divide that by 2. That gives me, certainly you can't really see that, 67.5. I'll write it over here so you know where I've got that from. And 67.5, and obviously this one's also 67.5, isn't it? Because it's an isosceles triangle, like these two sides are obviously the same. Obviously it's not equilateral, because otherwise they'd all be 60, wouldn't they? So you've got that. I guess, what do we want to know then? We want to know the area. I'm thinking either trig or the other one. This is probably where you could do it different ways, because obviously the area of a normal triangle is half base times height. We've got the base. We'd need to know the height. So you could work out the height, I guess, if you wanted to. Using the 67.5, you could split that into another triangle. The other area, as you've said, the trig version is half AB sine C. But again, you would need 2 sides. So this is where you've got the option. You can either use half base times height, but what you would have to do if I get another line, I mean, either way, you'd have to, if I draw a line there, do you see how that would be 90 degree? Like I'm drawing it, so it's a 90 degree. So that's a right angle. You could either use this to work out effectively the hypotenuse and do the, as you said, half AB sine C, or you could use this to work out, what would that be? That would be like the opposite, wouldn't it? The height, effectively, and do just half base times height. So I think that's probably an option. We might as well go with just half base times height, because it's a bit easier, I guess. But I'm going to have to use normal trig, SOHCAHTOA. So I want to know this side, which is the opposite, isn't it? This vertical side. But just remember, because I've split this in half, technically this side here, the base of this triangle is 0.4 meters, isn't it? Not centimeters, meters. So just remember, you need to half that. And then that side, what's that? That's the adjacent, isn't it? So you could work out the hypotenuse if you wanted. You could work out the opposite. It doesn't really matter. I'm going to work out the opposite personally. That's what I'm going to do. So we obviously need to use tan, because I've got O and A, and I'm looking for O, so I need to multiply tan 67.5 times the adjacent, which was 0.4. Don't forget to change that to 0.4. 67. There's probably a different way to do this, but this is just my thought process, if that makes sense. Tan 67.5, to put that, obviously put that in the calculator, it's a calculator question, times 0.4. Oh, really nice number. Loads of decimals, so that's great. 65 dot, it goes on, right? So I'm going to try and keep that in my calculator, keep that answer in your calculator. Dot So that's my height. So now area of a triangle, half base times height over 2, whichever one of those, same thing, isn't it? Now I'm doing the whole triangle, right? The big triangle. So 0.8 times by this answer. So keep that answer in your calculator so you don't get rid of any of the decimals. Obviously, I'm just not writing them down because there's so many. Over 2, so maybe that's probably best if I show you on my calculator digitally, isn't it? Let me get my calculator. So I would have done tan 67.5, obviously close your bracket, times by 0.4. That's the long number that I got, right? This is the long number. Now take that, multiply that by 0.8, and then you can half it, obviously divide it by 2 because it's a triangle. Is this? That's one triangle. 0.386 ... Again, keep that number in your calculator. Now, don't forget though, because there's so many things to remember, isn't there? There are 8 triangles, so we need to times that by 8, don't we? Okay, that's slightly better. 3.09. So 8 triangles. I'm going to write it like that so I remember what all these numbers are for. 3.09 meters squared. So that's the area I got for the octagon. If you did it a different way, I'm assuming that's fine as long as we've all got the same number. I don't know if you have the mark scheme that because you sent this in. If you have the mark scheme, so make sure I'm on the right lines at least. So that's that. Now try and remember what we were actually doing in the first place. We were trying to find the volume of that. The volume of the 2 pieces, but let's do the prism first. You just work out the area of the whole face, the cross section, which we've done. And then we times it by the height. So in this case, it's 1.73. So I'm just going to take that, again, copying my answer, not getting rid of any decimals. 1.73. So the volume of the prism is 5.346. Let's write that down. So the volume of the prism, I like to label it just so I know what all of these numbers are. 0.09 times by 1.7, just so you know what I've done. No, so I found the area of the whole triangle. Do you see how I use 0.8? That's the whole base, isn't it? So I found, if I get my highlighter, yeah, this is GCSE, Dean. It's just one of those wild questions at the end that are a bit, you know how there's one question normally at the end that's really hard? I did the area, this is this area. If you did the area for half of the triangle, then obviously you'd have to times it by 16, wouldn't you? It doesn't really matter. It just depends which one you did, obviously, so you just relate it to however you worked it out. What number was that? I've already forgotten. 5.346. Right, okay. 5.346. I don't know if you can still see that, hopefully, just about. Okay, so that's the volume of the prism, so maybe I'll highlight that just so I remember. This is one of them, isn't it? Okay, now the only thing left, the only thing missing is the volume of the pyramid. Which, by the looks of this formula, you basically work out the cross-section and times it by the height and then divide by 3. So I guess that's not too difficult to memorize. Maybe you needed to memorize it. I was surprised you did need to know that. I thought they would have told you that because it's not a prism. So that's kind of interesting. But normally they'd put the formula in the question, wouldn't they? And they haven't, obviously. So yeah, who knows? Okay, so we've worked out the area of the octagon, which was this yellow one here, 0.386. So what I'd probably do in my calculator, so I'd probably go backwards. Sorry, that was one area, wasn't it? So it's the 3.09. So that's my area of the whole octagon. Now they've said for the pyramid, I need to times that by the height, which was 0.68, and then you divide it by 3. So you see, I've still got all of my decimals here. So 0.7 effectively that is, isn't it? So let me write that in. 3.09, which was the area, times by the height, 0.68, over 3. And that gave me roughly 0.7, didn't it? Meters cubed. That one's meant to be meters cubed. Because we are now in volume. Meters cubed. There we go. Okay, so now we're on the last bit. Volume of the pyramid. There we go. Now I guess we just add them together. It's a compound shape, isn't it? So total volume would be the 0.7 plus the 5.346 ... So I'm just going to take my whole answer there. Plus, what was it? 5.346. So what do they say to round it to? Okay, so now that I'm at the end, now I'm going to actually round this, okay? Now that I'm at the end. Yeah, so this volume down here, the one at the bottom is the volume of the prism, and then this one up here is of the pyramid. Obviously, they need to be separate because they're two different shapes, aren't they? Yeah, so they said round it, because see how I tried not to round anything until right at the end. That's what I try to do personally. Sometimes it's quite hard to do that, but I try not to round anything until the end just so I can get the most accurate answer. So now I can round it because it is the final answer. 3 significant figures, as you said, 6.05, because obviously 6.04, and then the 6 after that rounds it up, doesn't it? So that's what I would have put for my answer. I don't know if you have the answers there. I don't know if you have the mark scheme and if we can say if that was correct or not, because I don't have the mark scheme. But that's what I would do. Again, I think there was a lot of different methods to use at the start. It was mostly the start point. Finding the area of the octagon, that was, I think, the hardest bit. Beyond that, you're just using formulas, aren't you? And obviously it's just annoying because the decimals are kind of annoying numbers. But yeah, I don't know if you have... You don't have the mark scheme. Do you know what paper it was from, or you just have this as a random question? Because I've never seen this question before. So it's either because it's a 2024 question, or maybe it's an old, maybe it's an old question. Maybe it's from before 2017. Because you can access all of those. You can still access all of the papers in the previous syllabus. So I don't know. Yeah, I don't know what paper this is. I don't know if anyone else recognises it. Maybe I can Google it, see if it tells me. I would say it's obviously, it looks like it's Edexcel in the first place, isn't it? Edexcel, GCSE, maths. And I'll just type in the question. A greenhouse consists of a pyramid on top of a prism. Let's see if that comes up. Which paper is this? No, not that one. Not coming up immediately. Oh. I think. Well, I've tried to Google it. It says this is from June 2002. 2002. This says. I don't know if that's right, but that's when I googled it. This is what came up. 2002. Wow. So this was a completely different syllabus almost. I mean, obviously the topic is still the same, right? We still, I think this is reasonable. That's probably why they didn't give you the formula, because I think now they would. I'm pretty sure now they would, but maybe originally, like, how long was that? 23 years ago. Maybe they didn't give them the formulas. But that's why I was surprised, because I was like, obviously the prism, they won't give you the formula, but I'm pretty sure if it's not a prism, which a pyramid is not a prism, is it? I'm pretty sure for the volume of the pyramid, they would give it to you in the question. So yeah, that's what I mean. When I've Googled it, that's what's come up. Says June 2022. As you said, it was obviously a calculator one. So the paper used to be 2 hours long, so that's interesting. 100 marks for the paper. So yeah, they've obviously, changed the layout and the format and all of that since then. But I think it's still reasonable that they could ask you this type of question now. I think that's fairly reasonable. I just think they would give you the formula for the pyramid. This was the final question on the paper as well, and just, it's 7 marks. 7 marks this question, so that makes more sense, doesn't it? I don't know, I've not tried to access them. I just Googled it and it came up, like, the whole paper came up on Google. So if you I typed in Edexcel GCSE Maths, and then I typed in the first, like, this sentence up here, a greenhouse consists of a pyramid. On the student room it came up. I don't have the mark scheme though. Well, we could look up June, couldn't we? I mean, you can obviously practice all of the old papers. I mean, they're all, as long as it's still the same exam board, I think it would be fine. Obviously, you might not have time now, but I'd imagine that the teachers have access to the 2024 papers just because they would have given them to you as your, like, if you're in year 11 this year, that would have been your mock paper in December, wouldn't it, or January, or whenever it was. So I would imagine that the teachers have access to them. Yeah, I'm not a teacher, hence why I personally didn't have access to it. I'm just finding the mark scheme just so we can make sure that I've told you the right thing. Wow, this is old. Okay. What is this? Question 7? No, I want more than question 7. That's not right, is it? Let me just see. This look like the mark scheme. It only goes up to question 7. I don't know why the mark scheme for 2002 only goes up to question 7. So yeah, I don't know. Maybe you'd be able to find the mark scheme somewhere. It would be somewhere online, for sure. But yeah, for some reason it's only the first 7 questions that I can find, which obviously is the last one. How long is each paper? It depends what your exam board is and everything like that. If you're doing IGCSE, if you're doing normal GCSE. For the normal GCSE, and if you're doing Edexcel AQA, normally they are 1.5 hours long, and there's 3 papers. But it depends what type of your GCSE you're doing. That's the thing. Yeah, it looks like they've combined a load of old questions, which is quite good. Yeah, it was a good one to practice, but yeah, I think they would give you the formula for volume of a pyramid, I think, nowadays. So I think that would have been a bit easier. But it is all, whenever you see a polygon at the end of the paper, normally it's something to do with trig somehow. Normally you've got to split it up into trig, even though it's polygon. Okay. Alright, so yeah, so it's taken us a while to go through a few questions today, guys. So Reese wanted to go through ratio. I don't know, Reese, if you're still here. If not, I'll move on to the next question in the list. No, it's taken a while for us to go through. So Reese, let me know if you're still here. If not, then I will carry on for another question. I think Emily is next. Emily, are you still here? We can look at your question again. If not, I'll keep moving. Let me see who came after Emily. Yes, Emily's still here. Okay, we'll do your question and then that might have to be it for today. Okay, I'm just scrolling back through to see your original question. Median, mean, mode, when given either the range. Find the mode when we have... Oh yeah, when they give you a list and maybe one of them is missing. I think Maths Genie has some questions on that. Let me have a look. Okay. Quite good. Paste it. Why does it not let me paste it? Okay, let me just download it and I'll upload the whole thing. Because for some reason it will not let me paste. This is from Maths Genie. If you go onto their GCSE revision, and I just kind of search, like I do Control F, and it opens up a search bar, and I type in like mode or something, you can find this. So the one I was thinking of was these few here, the ones where at the end. So I'll look at 10 first. So here is a list of 7 numbers. One of the numbers is hidden. We'll look at this one afterwards because it's got 2 missing ones. One of the numbers is hidden. The mean of the numbers is 9. Find the value of the hidden number. I don't know if that's kind of the type of thing you're looking for. So I'm starting off with this one because I think, even though it's question 10, I think that's probably easier than the other one. So we'll do the other one afterwards. So the mean of the numbers is 9. So technically for this one's fairly straightforward, because technically to work out the mean, you would add them all up and divide by how many there are, wouldn't you? So I'd put, yeah, you said X. You could list that one as X if you wanted. If I add them up, what do I get? 11 plus 6 plus 7 plus 10 plus 7 plus 9. 50. Oh, okay. This one's got mode. That's what I was thinking. Find the range. What do you mean? I'm trying to think what else you might mean by that. And then obviously 1, 2, 3, 4, 5, 6, 7, and then you just revert, like that's just your equation, isn't it? You can reverse that. One with a range. Maybe if I look through the Edexcel, I feel like I kind of know what you mean. Let me just see statistics. Maybe just check through my Edexcel questions, because I feel like I know what you mean, but it's not quite fully there. No, nothing there. Quite a niche question, I think. That's the problem. Histogram mean questions, frequency, no. That's not any of those. Calculator. I don't have any questions on range. I thought it was when you had like 2 missing and you had to find out the other one. Yeah, if you've got one specifically, then that would be great, just so I can kind of more specifically help you. Yeah, you can send me another question. Yeah, let me know if you've got one specifically, and then we can open that one. That will be more specific, won't it? Question 2. January, which year? Wait, January? January 2021. Oh, GCSE. Okay, yeah. Hang on. GCSE, January 2021. Paper 2. Oh, I see, yeah. 3 marks. Okay, yeah, perfect. Right, let me get this. I'm gonna paste it. Might just have to upload it. GCSE, let's just go through this way. Proportion I have videos on. If you look through my channel, you can see that I have videos on proportion. So yeah, you could have a look, direct proportion, inverse proportion, things like that. I think there's like 4 videos on it. You can have a look and see, they would be there. Okay, this better, we can see this now. This question here. Okay, so Ava writes down 5 whole numbers. For these 5 numbers, we've got the median. Oh, okay, interesting. So you don't know any of the numbers. Okay, the median is 7. The range is 5. The mode is 8. Find a possible value for each of. Okay, so I'm thinking the first thing. All right, let's put like kind of lines, right? The median is the middle, so this one has to be 7, right? And that one I'm just going to put. I'm assuming that one's 7 because it's an odd number. If it was an even number, I guess it's a little bit more difficult, but because it's an odd number, I'm going to put 7 there and just, yeah, because that one would be the median, wouldn't it, if they're in size order, right? Now, they said the mode is 8, so 8 would have to be at least 2. But do you see how, because 7 is the middle, you couldn't have more than 2 8s? So that's kind of my first thing. So that's that. Then they've said the range is 5. So because, you see how I now know that 8 is the biggest number? Because of the fact that the median was 7 and because of the fact that there's then 2 8s, there's nothing bigger than that, is there? So then obviously the range, if I take away 5 from 8, that would be 3, which is the smallest, so that would have to be 3. And then it says, because it says a possible value, it's, you know, there's probably multiple answers for this last bit here. You just write any number between, obviously it can't be 3 and it can't be 7 because otherwise then that would change the mode. But it could be, they're obviously whole numbers, it could be 4, 5 or 6. So you could choose any. I think they would, if you look at the mark scheme, I'm sure they would allow any of 4, 5 or 6. So I could put 4, 5 or 6. That's kind of, I think they've put it in order that way as well, deliberately. That's what I would do, just piece it together from there, if that makes sense. That's literally all I would do. But yeah, I think this one they would allow 4, 5 or 6. That one technically could be any, couldn't it? It's not really more specific than that. That's literally all I would do, yeah. So yeah, maybe just drawing the lines, visualizing it in size order, that probably helps. Yeah, that's what I would do for that one. Oh, there's my alarm. Okay guys, I don't have any more time today because I have something else I need to do at 6 o'clock. But I will do, I think I'll do another one of these tomorrow anyway. So the email you sent me, we can look at that one tomorrow or whenever you come to the next Q&A. Any other questions? Yeah, I think I'll do a Q&A probably about 5 o'clock tomorrow. And then I have a past paper again, paper 1, because obviously that's this week. Paper 1 non-calculator will be at 7 o'clock tomorrow. Tomorrow also the predicted paper that I've written will come out as a video. I know we went through it in a live last week, but as an actual edited video, I think it will be a lot shorter. The predicted paper that I've written for paper 1 will be uploaded tomorrow morning if you want to go through that, and obviously it will be linked in the description if you want to download it and practice it yourself. Yep, the email you sent me will go through that tomorrow, okay? That one there, I've seen that one. We'll go through it tomorrow because I need to finish the live here. So thanks for joining me today, guys, and I will see you tomorrow.